So as most of you probably know, for the PID Graph component, we've got a couple of subcomponents, different parts of it, which we're working on to provide this kind of unified service that's called the PID Graph overall. And so the main part we've done for the beta release as a new thing, which is something that's not existed before, is this DataCite metadata dump. So a few people have contacted me about that already, just to say there will be, as part of the component, an API for accessing it, so you will be able to get it from the DataCite API. At the moment, for the beta release, if you want access to this, just please drop me an email, and I will provide you access to the file. But in the main part, this is a sort of segregated JSON dump of all of the DataCite DOI metadata. So all the metadata provided to us by DataCite users, and it's just segregated by DOI prefix to make it easier if you are interested only in accessing parts relevant to your repositories or DOIs you know about. You can sort of open the individual prefix folders. Inside each folder, there's a series of JSON files. These are split up into 1,000 records each, so as not to have a whole bunch of huge files. This is following the guidelines of the scholarly knowledge graph interchange format, which came out of RDA. It's being worked on with some people from OpenAir, ourselves at DataCite, Crossref, Open Citations, a few other organizations involved there, including some other EOSC partners. So this is the recommendation for how to split up large data files as JSON, to make them interoperable with, other people doing graph outputs. So also, I think the OpenAir data will be released in a similar format. So inside each of these files, if I pull one, okay, you see we have a list of DOIs. You have all the attributes. So this is following the same format as the DataCite REST API metadata. So if you have tools already that can parse and deal with that, then you'll just be able to go straight through this data and pull out the bits you need, whatever you're interested in. So as you see, if I scroll down here, it's a bit bigger. There's just in this one 1,000 records, or slightly less because this is from a smaller repository. And it's just a big JSON file. There's no top level key, it's just an array, so you can just open the file and start reading the data out. And this means that you can use tools such as JQ to go through the data. So, for example, I've already copied the JSON in here, but if you just wanted to pull out a list of all the DOIs, you can sort of use a JQ. I don't know if people have come across JQ. It's a very useful command line tool for parsing and going through filtering large JSON files. So here I'm just putting out a list of the DOIs, as you can see in the output here. But you could do some useful things. So for example, we've had a use case from Clarin, and they're interested in doing reverse lookups between URLs and their DOIs. So for example, if you pulled out the attributes key, which is where all the metadata is, you could then select just the DOI and the URL, and this will give you a nice kind of set of key pairs for DOIs and URLs. So you could use this to efficiently kind of go through the data dump and extract only the bits of data you're interested in. This will be significantly quicker than sort of making, thousands of requests to the REST API. So we really hope to see uptick of usage for the data dump for people who are interested in sort of en masse harvesting or analysis or linking of data from DataCite metadata. And you can start to do kind of a lot more advanced things, especially with JQ. If we want to look to, for example, here, just to pull out a bit more information, the DOI, the URL, the title and publication year. So it starts to give you things where you could, use this to build landing pages or matching in your own systems or some integrations. And because it's all there as JSON, you can also do useful things like filtering. So if we see here, like the publication year, the top ones, 2003, 2006, 2007. But what if we're only interested in sort of like slightly later things? So you could put in here, for example, select publication year more than 2010, let's say. So now, as you see, we've produced a filtered list of the JSON. So in terms of speed of making queries, of analyzing the data, I think using this data dump with all the metadata already there and then doing the filtering locally is still quite efficient, actually, compared to doing the REST API, especially if you're interested in large amounts of data. The total size of the data dump file itself is about 300 gigabytes when extracted, but the actual thing to download is only 24 gigabytes. Obviously, text compresses quite well. Part of that is due to some repositories. We have some people who provide us with a large amount of metadata. So you may actually see this decrease in total size in the future. So another example of the sort of things you could do with a data dump, the repository which provides us a huge amount of data in terms of the descriptions is GBIF, the Global Bioinformatics Forum. I can't remember what the F stands for, I'm afraid. So, for example, I wanted to do some analysis around the descriptions they're using and the length of the description. So I thought, okay, I'm going to pull out some basic data again here with a couple of lines of Python. I was able just to recurse through the data dump and extract some bits of information I needed. And in this case, I'm just spitting them out to a CSV. So you can do quite a lot with this. You can do more analysis, more useful things than are available just in the kind of REST API, which is obviously geared just towards retrieval of data. So the second part of the component is for doing graph-based queries. So we have a GraphQL API. We've been making enhancements to this as part of Faircore for EOSC, adding support for more filtering, more queries, more aggregation options for traversing through the graph. So there is here, it's linked in the useful links section of the agenda, the GraphQL API guide gives you some information about what you can find in there, some example queries, and we have a GraphQL playground. So if you don't have a GraphQL client to hand, you can experiment here in this thing here. It's api.datasite.org/GraphQL. And if we look, for example, here, this is an example query where I say, okay, I'm interested in publications which match the query climate. So the data you can receive here is slightly more than just DataCite data, where records from other registration agencies, such as Crossref, have links to the DataCite, to a DataCite DOI, then their data is pulled in and incorporated into this, into the GraphQL, because it's obviously based on graph querying. This is not a universal query. If you look up, for example, Crossref DOIs that have no relationship to a DataCite DOI, you will not find anything in here, but you will get Crossref DOIs when they are related to DataCite DOIs. So here I've sort of selected, it's a little bit bigger, a few different bits of metadata. I don't want everything, but I'm interested in the titles, descriptions, creators, funding references. And you can see you get back this sort of like standard blob of JSON. So with the GraphQL API, you can make some quite advanced queries. So for example, if I look at this one here, this is a large query where I want to get a lot of information about an organization, in this case, the Tula Foundation, and this is done via the raw identifier, so the Research Organization Registry, persistent identifier, which is in the graph. But you could query on the grid identifier or the Crossref funder identifier, and various other types of filters. So there's quite a lot of, you can look at the language, maybe the field of science, code for the repository. And here I'm asking for lots of information about the organization itself. But then also in this works, I want to look at the first sort of 25, give me the first works returned that are associated with this organization. And here you can see that I'm pulling out also then some analysis. So we have this fragment, work connection fragment on a work connection with total. So this is basically faceting against the entire graph associated with this organization. So if I scroll down the results here, you'll see we have the various bits of information, including country. So this is useful for some of the case studies have a use case where they want to filter for research outputs associated with a particular country. And as we scroll down here, you can see now we start to see some facets. Here are the types of works that are represented inside this organization. So we have data sets, journal articles, output management plans, software reports, etc. Some information on the license types, on the languages, the fields of science, identifiers, the authors, where the DOIs there are registered. So you see actually there are 32 DOIs we know about at Crossref associated with this organization. And likewise for the authors, you can see we're linking out to the ORCID as a persistent identifier for authors of scholarly outputs. And then when we get down to nodes, now you can actually see the information I've asked for about the individual works, the actual outputs connected with this organization. So this is, it's a fairly comprehensive way of traversing the graph of data that we know about. Likewise, you can look up information on an individual DOI, which will give you all of the associated resources as well if you ask for it. So here, we're looking up just a basic work. So the query is by identifier, which is the DOI. And then I'm asking for citation information. So show me all the works which we know about inside the graph, which have cited this particular identifier. Also references, any other relationships, so if it's part of another work or it has a part of, and other related identifiers. Sorry, excuse me 1 second. So you can see from this query that we're again getting just the information about the actual resource itself, which in this case is a data management plan. The usual things, the description, the creators, all of the normal metadata that you would expect to see from GraphQL. And then if we go down a little bit here, we have some of the fasting information about the related identifiers. So if we look down here now, this starts to be the information about the DOIs and other identifiers that are related to this identifier. So now we're starting to look at traversing through the graph for other resources. So you can see, for example, this one here. This is an OUP journal article, which is part of the outputs from this data management plan. So this is another Crossref DOI, so you can see that we're covering everything we know about in the graph, rather than just DataCite DOIs. Obviously, the GraphQL like this can be a little bit busy and confusing. So you can see, for example, we have DataCite commons, and this is the same data. So using the same GraphQL query, we have this kind of display of the metadata. So you can see now with the facets, we have more things like the publication year, the work types, and then in the related works, now you can see actually, okay, here are the objects that appear. This is what we were just looking at in the GraphQL output. So you can use this to traverse the graph a little bit further. And the last thing we have as part of this component is the DataCite usage tracker service. So this is in beta release. This is a little for people who have DataCite DOIs. This is a small JavaScript widget that you can put on the landing pages of your DOIs, and it will collect and submit counter compliance statistics to the DataCite usage statistics service. And this data will then appear in all of the outputs, which you've just seen. So inside individual pages, inside GraphQL, inside the records, you see that there's like view count, download count, reference count, citation counts. So if data is submitted to the usage statistics service, it will appear here in the output of the data dumps. It will appear inside the GraphQL outputs. It will appear inside the DataCite Commons view, and you'll be able to have your counter compliance stats for usage as part of the data that's available for people to download. So I'm going to just stop the sharing there so I can see everybody's faces again. So that is a brief overview of the components that have been released as part of the beta release, the MVP for Fair Call for EOS month 18. So I'm happy now if people have questions, etc. We can start to look at those.